How we doing there, guys? So today we've been taking a look at telling the difference between elements, compounds, and mixtures. That's a target that we've been working on. And today we're going to do a lab where we're going to look at some of the properties of some different elements. We're going to take a look at aluminum, carbon, iron, magnesium, silicon, sulfur, tin, and zinc. And we're going to take a look at some of their properties. We're going to see, do they conduct electricity? We're going to see, do they react with hydrochloric acid? And we're going to see, do they react with copper 2 chloride? So let's go ahead and let's take a look at this lab and see what are some of the properties of these different elements. Okay, before we get started, there are some questions for us to answer before the lab. So let's take a look at some of those questions. The first question I see here, it says, what will happen if hydrochloric acid contacts the skin? How can you protect against this hazard? Okay, well, hydrochloric acid will burn, right? But the hydrochloric acid that we're using is not very concentrated. It's only 1 molar hydrochloric acid. It's low concentration. It's unlikely to burn you. But if you do get it on your skin, what you should do right away is go over to the sink and rinse it off. That's probably the best safety precaution here. So for number 1, I would say, if you get some on your skin, rinse it off right away. For number 2, it says, using a periodic table, determine the chemical symbol for each of the 8 elements to be tested. Write the chemical symbol for each element next to its name in the data table. So the lab wants us to make a little data table and put the names of the 8 different elements we're going to look at on there. So what I'm going to do is I'm going to divide this into 8 sections. 4, 6, 8 different sections. Okay, and let me see, what's the first element that we're dealing with here is aluminum, right? So in one of these I will put the symbol for aluminum, which is Al. The second one that we're dealing with here is carbon. So for my second one, the symbol for carbon is C. Alright, the third one is iron. Iron, if we look, is Fe for iron. Okay, the next one we've got is magnesium. Magnesium, so Mg. After magnesium, we have silicon. Silicon. Is Si. Okay. After silicon, we've got sulfur. Sulfur is S. After sulfur, we've got tin. Tin is Sn. And finally, the last one is zinc. Zinc is Zn. So that is question 2, is to make our little data table with the symbols for each of the different elements that we're going to be working with. Okay, let's check out the third question here. The third question, it says, identify each of the following as either a physical or a chemical property. Okay, the first one, it says butter melts in a microwave. Whenever you're talking about something melting, that's going to be a physical property. B, it says a piece of carbon metal feels cold to the touch. It's how it feels. That's going to also be a physical property. An apple slice turns brown in the air. Well, we can see some discoloration there when the apple slice turns brown. That's going to be a chemical property. A watch dial glows in the dark. That's another physical property. That's just how it looks, right? An iron nail rusts. Well, something rusting, something oxidizing, that's a chemical property. It's reacting with the oxygen in the air. It's a chemical property. And finally, bleach is used to remove a stain from clothing. That's changing its color. That's going to be another chemical property. So there are questions to answer before we get started on the lab. Let's go ahead and let's get started, and let's take a look at some of these elements. Alright, so the first thing we want to do is we want to obtain a sample of each one of these 8 different elements and put them on our paper. The directions say to put a little sample on the square for each different element. So the first one I have here, I have some aluminum, and I've got myself a scupula, and we're going to need 2 pieces of aluminum. So I'm going to take just 2 pieces of aluminum, and I'm going to put them right there on the symbol for aluminum. Okay. Then we need some carbon, and here I have some graphite powder. Graphite is carbon. Carbon comes in a couple of different forms. One of them is graphite, the other one is diamond. We're not going to use diamond in this lab, so let's get some graphite here. A little bit of graphite there. Okay, the next one there, iron. I have some iron wire. So let me grab my wire cutters. Get a little piece of iron out here. That little piece of iron. Let's make that 2 little pieces. Okay. Next one we got there, magnesium. I have some magnesium ribbon here. I'm gonna use my wire cutters again, and I'm gonna get a couple little pieces of magnesium ribbon. Little pieces of magnesium there. Okay. What do we got next? Silicon. Here I have my silicon. Get a couple of pieces of silicon. Silicon, you can see it kind of looks like a shiny rock. I want some smaller pieces. Yeah, I'm just going to take 2 fairly small pieces of silicon. Next we got some sulfur. Here I got a whole bunch of sulfur. I'm going to take my scupula, I'm going to get a little bit of sulfur. This is a powder. A little bit of sulfur. Then we'll need a couple pieces of tin next. There's some pretty small pieces of tin in here. Gonna get a few. Put them on there. I'll go everywhere. And then finally, zinc. And here's my zinc. Pieces of zinc here. Okay, so now we've got our elements. We're going to go ahead and we are going to test first their conductivity. Okay, so the next part of the experiment here, it wants us to test and see whether each one of these is a conductor. Now, they make what's called a conductivity meter. I don't have a conductivity meter, so what I've done instead is I have rigged up kind of a little way to test for conductivity, right? So I have a light bulb, it's attached to a battery, and then I've got the ends of 2 wires, and if I touch them to something that's a conductor, the light should come on. So first the aluminum here. Let's test the aluminum, and you see the light bulb comes on. That's a conductor. Aluminum conducts electricity. What about carbon? Carbon, I got nothing there for the carbon. But hang on one second, let's take a look at something. Okay, I have a feeling that carbon isn't conducting electricity because it's a powder. So now I've got this carbon rod here. It's a stick and it's made out of carbon. So let's test this, because carbon should conduct electricity. So there you go, it lights up. I have a feeling that's not working for us there because it's a powder and it's probably just not conducting the electricity well because it's a powder. Alright, let's try the iron. Piece of iron. Put some iron here and see if that conducts electricity. Yep, there we go. Iron conducts electricity. What about magnesium? Some magnesium here. Magnesium conducts electricity. How about this silicon? Let's try this silicon. Oh, look at that, it does not conduct electricity. Silicon is not a conductor. Okay, we got some sulfur here, and sulfur is not going to conduct electricity. Sulfur is not a conductor. We got some tin, little bits of tin. Some conducts electricity. And then finally my zinc. Zinc looks a little oxidized. I hope it works. Zinc, conducts electricity. Alright, so we've looked at which ones conduct electricity and which ones don't. They all conducted electricity except for the silicon and the sulfur. Okay, now we're going to take each one of these and we're going to put them in a little test tube, and we're going to add some hydrochloric acid to there, and we're going to see if they react with hydrochloric acid. So let me take a little piece of aluminum here and add a little bit of hydrochloric acid, and let's leave that sit for a minute, see if anything happens. Okay. The next one here we got is some copper. I'm sorry, some carbon. There's carbon in here. Add some hydrochloric acid. And we'll leave that sit, see if anything happens. I'm going to take a piece of iron. See if anything happens with the iron. Some magnesium. You can see right away. It's fizzing and bubbling. Yeah, magnesium definitely reacts with hydrochloric acid. Let's put that down. Check out some other stuff. Got some silicon. I don't think my silicon's going to fit in the test tube. Maybe I can get a smaller piece. That there, see if anything happens. Get some sulfur in here. Put that down, see if anything happens. Piece of tin. Pieces of tin in here. And finally we get a piece of zinc. Zinc is probably too big to go in the test tube, so I'm going to put a little piece off. You can already see there's some, not as much as the magnesium, there's some bubbling going on there. So you can already see the magnesium and the zinc react with hydrochloric acid. So let's see if we have anything else going on. really seeing a whole lot on the aluminum. There might be some little bubbles in there. So I'm gonna say there's a reaction going on, but it's not a very strong reaction. With the carbon, don't really see anything happening with the carbon. I'm gonna say there's no reaction there. The iron, I don't see any reaction happening with the iron. Magnesium definitely had a reaction. We still have a reaction going on. It's still continuing. Silicon, there's nothing happening with the silicon. There's no reaction. Same with the sulfur. There's nothing happening with the sulfur. Nothing going on. With tin, I don't see anything happening with the tin. And then finally the zinc, that reaction is still going on. You can see it's all bubbly and it's still reacting, it's still happening. So there we go, we can see some of them react with the hydrochloric acid and some do not. Okay, so the last part of our lab here, it wants us to see which of our elements is going to react with copper 2 chloride. And here I have this nice pretty blue stuff. This is copper 2 chloride. So what I'm going to do is I am going to take the top stopper off of that. I'm going to put some of our element into a test tube for each one of our elements. And then we'll put some copper 2 chloride in there and we'll see what reacts. So there was the aluminum, there's some carbon, there's a piece of iron in here, there's a bit of magnesium ribbon there, a piece of silicon in there. Sulfur in this one. I'll get a couple of pieces of tin. And then finally, a piece of zinc in this one. Alright. So I'm going to take my pipette and I'm going to put some copper 2 chloride in each one and we'll see what happens. Now, you can see a few reactions starting to happen here. If you look at my aluminum, it's got some bubbles forming on it. It tells me there's a reaction going on. The carbon doesn't look to be doing anything really at all. There's like a mess in there. Iron, I don't see anything happening there just yet. The magnesium is definitely reacting. There's bubbles being formed, you can see the color changing. I can hear little bubbles popping in there, some little fizzing. Let's see, silicon, I don't see anything happening with silicon just yet. There's nothing going on with the sulfur here. Let's see, the tin, there's a couple of bubbles on the tin. Not a whole lot though. A couple of bubbles, but not much going on there. And the zinc, well, the zinc's turned all black. Okay, so we can see a reaction happening with the aluminum. We can see definitely with the magnesium, and the zinc is already reacted. It's just totally black at this point. Maybe a little bit with the tin, and I don't see anything with the iron. So we have a reaction with the aluminum, with the magnesium, with the tin, and with the zinc. And the other ones have no reaction. Hey, so I have left these test tubes here for a little while, and I came back, and some of the reactions are now quite obvious. If you take a look at, here was the aluminum with the copper 2 chloride. You can see it's grown this brown stuff. That brown stuff is copper, and the blue has gone out of the liquid. It's now clear. And let's see, still nothing has happened with the carbon. Here we can see on the iron, it's kind of cloudy down towards the bottom. Some of the blue has gone out of the liquid, and there's a little brown buildup on the iron wire, maybe you can see, right? So there's been a reaction there. Let's see, with the magnesium is reacting quite a bit. You can see it looks kind of dirty in there. There's some powdery stuff on the bottom, and a lot of the blue has gone out of the liquid. So definitely a reaction with the magnesium. Let's see, the silicon still has done absolutely nothing. This one was the sulfur has still done absolutely nothing. But now this one was the tin, and you can see something's happened. Some blue has gone out of the liquid. There's still a little blue in there, but it's a lot less blue. And you can see some cloudy stuff on the bottom by the tin. So something's happened there. And then the zinc had just, reacted really quickly at the beginning. So there's no more blue in the liquid, and the zinc's turned black. So some fun things you could see with those reactions after leaving them there for a while. Okay, so real quick before we wrap up this video here, let's take a look at the PostLab questions. The questions for us to answer after we're done with the lab. The first one says, review any data for the 8 elements. Sort the elements into 2 groups based on similarities in their physical and chemical properties. Explain the criteria that were used to separate the elements into these 2 groups. Now there's lots of different ways you can do this, but one good way would be to separate them into metals and non-metals, right? And if we sorted them that way, the aluminum, the zinc, the tin, the magnesium, and the iron, those are all metals. And if we were to take a look at the other ones, silicon, sulfur, and carbon are all non-metals. Are there any borderline elements? Meaning, do any of the elements appear to have properties of both groups? Well, again, there's ways you can look at this. You notice that carbon is a non-metal, but it conducts electricity. Silicon is what's called a metalloid, so it really is one of these borderline elements, right? It's not really a metal, it's not really a non-metal, it's kind of somewhere in between. It's a metalloid. Number 3 there, it says metal, non-metal, or metalloid. A shiny, malleable material that conducts electricity, that's definitely a metal. B, it says some properties are common to both metals and non-metals, that would be a metalloid. It's dull in appearance, brittle, does not conduct electricity, that sounds like a non-metal. Most do not react with acids or with copper 2 chloride, sounds like a non-metal. Many do react with hydrochloric acid or with copper 2 chloride, that sounds like a metal. Number 4 there says look up the position on the periodic table for each element tested in the lab. Write a general statement describing the position of metals, nonmetals, and metalloids on the periodic table. Okay, so you'll find the metals over towards the left side of the periodic table. In fact, about the left 75%-ish of the periodic table is metals, with the right side being the nonmetals. And the few elements that fall right in between them there, those are the metalloids. Number 5, based on general knowledge of metals and the answers to questions 1, 2, and 3, classify each element as a metal, nonmetal, or metalloid. Okay. Aluminum is a metal, carbon is a nonmetal, iron is a metal, magnesium is a metal, silicon is a metalloid, sulfur is a nonmetal, tin is a metal, and zinc is also a metal. Okay, so that was the Properties of Elements lab. Hopefully that helps us to be able to tell the difference between elements, compounds, and mixtures. Until next time, take it easy.